This is the history of spaceflight and space technology. I'm Andy Chaikin. This is week 8, Apollo 12 through Apollo 14. Well, in November of 1969, it was time for NASA to try and repeat the success that they'd had with Apollo 11. Apollo 12 was scheduled to be the second lunar landing. Amazingly, Apollo 11 had accomplished Kennedy's goal. Nobody could have predicted, even a few months earlier, nobody could have predicted that by Apollo 11 they would have succeeded in accomplishing the lunar landing. But that, in fact, is what had happened. And so with Apollo 12, it was time not only to repeat Apollo 11's achievement, but to actually go one better. And here you see the crew of Apollo 12 in the center, veteran Gemini astronaut Pete Conrad, the commander. On the right, Pete's former co-pilot from Gemini 11, Dick Gordon, who would be the command module pilot of Apollo 12. And in the upper left, the rookie on the flight, Alan Bean. And they were an all-Navy crew, and their mission patch reflects that, showing a clipper ship. And their spacecraft names also reflected naval heritage. The command module was called Yankee Clipper, and the lunar module was Intrepid. Now, Apollo 12 had the goal of a pinpoint landing on the moon. Now, this was a goal that came about directly because of Apollo 11. When Neil Armstrong and Buzz Aldrin managed to land safely on the Sea of Tranquility, it was a tremendous achievement. The only drawback was for NASA was that they actually landed 5 miles beyond the place on the moon where they had been aiming for. Now, this was no consequence to the actual mission of Apollo 11, but it did have ramifications for the later missions because eventually the scientists wanted to be able to send astronauts to explore specific lunar features. Now, everybody at NASA knew that, and so even before the end of the Apollo 11 mission, in fact, while Armstrong and Aldrin were on the moon, and Mike Collins was trying to figure out where they were unsuccessfully, the Apollo program manager, Sam Phillips, turned to his deputy in Mission Control and said, "Next time I want a pinpoint landing." Well, that became the primary goal for Apollo 12. Now, a pinpoint landing, technically speaking, you could pick out any crater and say that's our target, and you could show that you had landed, close to that crater or as close as you possibly could and declare it a pinpoint landing. But people understood that that was not going to be a very impressive demonstration. So somebody had the idea of actually landing near one of the unmanned surveyor probes that were already on the moon. Several of those surveyors, of course, had landed in the mid-60s to try and scout what the lunar surface was like before astronauts went there. Well, in the end, they selected Surveyor 3, which they were able to locate using lunar orbiter photographs, the unmanned lunar orbiter images. And Surveyor 3 was resting inside a crater on the vast lava plains called the Ocean of Storms. And that crater is about 650 feet in diameter. And that became the target for Apollo 12. Now, if they were going to be able to actually land at this target, they had to develop some new techniques. And the most important one was that they would measure the velocity, the speed of the lunar module as it came around the moon just before making its final descent down to the surface. Now, the way that they would do that would be to measure the frequency of its radio signals as it transmitted radio signals to Earth. Now, why is the radio signal a measure of the velocity? Well, if you are pointing in your orbit, if you're coming around the moon, you are pointed as you come around directly at the Earth for a moment. Just as you come around from the far side of the moon to the near side, you are in fact traveling directly at the Earth. And therefore, your radio signals will display something called the Doppler effect, which is, if you've ever heard a passing train whistle change pitch, it would rise as it approaches you and lower in pitch, fall in pitch as it pulls away from you. That is the Doppler effect. Well, the same thing can happen with radio signals. And what it is that the speed of the emitting object, in this case the lunar module, actually causes the waves to become compressed, which results in an apparent change in frequency. So in the case of the train, as it's approaching you, the sound waves are being compressed, and that seems to make the train's whistle rise in pitch. As it pulls away from you at high speed, these sound waves are getting stretched out by the motion of the train, and that causes an apparent fall in pitch. Well, the same thing with the frequency of the radio waves. So using this Doppler shift, they would be able to determine whether or not the lunar module was traveling at the right speed and direction, i.e. velocity, to reach its target precisely. If it was not, they could create a correction which could be fed into the lunar module's computer. They would actually tell the lunar module's computer that the landing site had moved. That was the easiest way to enter the correction into the computer. And the astronauts would actually do this as they were approaching the moon, and that would be the way that they would remove any errors in their aim. What had caused the problem on Apollo 11's targeting was that there were a number of errors in their velocity that they were not aware of. And so this was going to try and solve that problem. Well, Apollo 12 left the Earth on November 14th and started out in a rather startling manner. It launched into a thunderstorm. Lightning actually struck the spacecraft as the Saturn V was pushing it towards space, twice in fact, 35 and 52 seconds after liftoff, knocked out the command module's electrical system. Fortunately, the Saturn V had its own computerized brain, which was unaffected, and it kept steering the command module towards space, and they got into orbit okay. They were able to get the electrical system fixed up, and the navigation system had also been affected, the computer and the navigation platform. They were able to get all that squared away, and they were able to head out to the moon. Well, then on November 19th, Pete Conrad and Alan Bean got into the lunar module Intrepid, and they started down towards the lunar surface. And in the next segment, we will pick up with that descent to the moon.